So an example of a negative exponent problem might be something like this. Let's say I want to understand what the value of the expression, let's just pick 3 to the power negative 4. And I want to understand what that numerical quantity is equal to. And that the same logic that we use here, we could also use for a variable expression like 5x to the negative 4 or something. So however we understand what's going on top, we'll also use that same understanding for what's going on at the bottom. So what do you think? What does it mean when we have a negative number up in the exponent? What are some ideas?
Is one of the numbers just negative? Because it's not in parentheses?
All right, so number's not in parentheses. The negative 4 here isn't in parentheses. If it were, the parentheses would still be up there in the exponent. So I think it sounds like what you're thinking of might be that classic thing that I try to trip you up with every time, which is something like that. Negative 3 to the power 4. So it's a little different having a negative number in the exponent compared to having a negative number in the base. In the example where we have a negative number in the base, negative 3 to the power 4, here at least as long as we have the parentheses, we can understand that means multiply negative 3 times negative 3 times negative 3 times negative 3. Right? And we know how to multiply something by itself 4 times. What's less clear is how do we multiply something by itself a negative number of times? That's what 3 to the power negative 4 would purport to mean. So yeah, what are some other ideas for 3 to the power minus 4? Here's kind of a mathematician's classic response to how to understand this problem. Let's say we don't know what 3 to the minus 4 is. I think we do know what 3 to the positive 4 would be. What is 3 to the positive 4? How would you find it? You would just have to multiply 3 by itself 4 times, right? 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th power is 81. So what should 3 to the negative 4 be? So there's one of the frequent possibilities, negative 81. Let's think about that for a second. Here's how mathematicians love to resolve this question. I don't know what 3 to the minus 4 is for a moment, but I do know what 3 to the power positive 4 is. And I know, because now we know the exponent properties, I know what's going to happen if I multiply those two quantities together. 3 to the negative 4 times 3 to the 4. What am I supposed to get when I multiply those two monomials together? What's going to happen? What happens to the exponents when you multiply two monomials? Add them together. So what exponent is going to go on my 3 here? Negative 4 plus 4. What's negative 4 plus 4?
Wouldn't it be 9?
The first observation is that the base remains the same when you multiply these powers together. So we end up with some number of powers of 3 when we multiply 3 to the negative 4 and 3 to the 4. Specifically, how many powers of 3 do we end up with here? None. So before we can talk about negative exponents, we have to make sense of an absence of exponents. What does it mean to raise a number to the power 0? If raising a number to a power means multiply by it repeatedly, so raising a number to the first means multiply by it once. Raising a number to the second means multiply by it twice. Raising a number to the 0 should mean to multiply by it how many times? None. To not multiply by it at all. So we need a number here that represents the idea of not multiplying by a quantity at all, but leaving everything the same. What number am I describing? Yeah, the number which has the property that it doesn't change anything that it multiplies by is 1. So 3 to the power 0 is another name for the number 1. So let's get that property off here to the side here. 3 to the power 0 is equal to 1. And that's true for any base that we use here, whether it's 3, whether it's -5, whether it's 2.6, as long as the base is not equal to 0 itself, any number raised to the 0 power is equal to 1. For any non-zero x. So that's the first thing that we have to reckon with before we handle, the idea of a negative exponent. Is a 0 exponent. X to the 0 is equal to 1. But now that we know that, what do we think about the idea that 3 to the power -4 is equal to 81? Negative 81, rather. If that were true, then this equation would say that negative 81 times 81 is equal to 1. True or false? Yeah, that doesn't work out. Negative 81 times 81 is, what is that, 600 and something? Yeah, it's definitely not equal to 1. Right? So negative 81 doesn't look like it fits the bill. So what does? What number, when multiplied by 81, is going to equal 1? Let's treat it like it's an algebra problem. Let's call this t. T times 81 is equal to 1. How do I find t? Get t by itself. Yeah, just divide both sides by 81. That's going to cancel these 81s. And it's going to convince me that t is equal to what? 1 over 81. And t here plays the role of 3 to the power -4. 1 over 81. So, here's what we're left to conclude. 3 to the power -4 is equal to 1 over 81. It's interesting. It's not even a negative number. It's a positive number, the fraction 1 over 81, right? So what is its relationship to 3 to the power, what is its relationship to 3 to the power 4? What's the difference between that and that? Between 81 and 1 over 81. How are those two numbers related? What do we call that? So the relationship between 3 to the -4 and 3 to the 4 is that they are reciprocals of one another. To raise something to a negative power is the same thing as instead of multiplying by it, we end up dividing by it repeatedly. So seeing a negative number in an exponent just means that that quantity belongs in the other part of the fraction compared to where it originated. If I look at x to the power -4, for example, by exactly the same logic, because the x to the 0 on the right-hand side of this equation has to equal 1 for any non-zero x. That means that x to the power -4 should be, if we divide both sides by x to the 4th, 1 over x to the 4th. So having a negative number in the exponent just means instead of multiplying by that quantity, we're instead dividing by that quantity. And another way to see it using our diagram over here is having a negative exponent really just means that we have switched sides of this layer cake. Right? Having a positive exponent versus having a negative exponent is the same thing as trading out multiplication for division. And that's all there is to it.